Humanoid robots. For most of human history, they existed only in stories. Creatures of metal and circuitry, walking among us in the worlds of imagination. We dreamed of machines shaped like humans, machines that could walk, talk, think, and help us. But dreams often stay dreams, until the world finally catches up. Today, in 2025, we are witnessing something extraordinary. Humanoid robots are quietly stepping out of fiction and crossing into everyday reality. Factories, research labs, hospitals, disaster sites, and even homes are beginning to test machines that resemble us more than any previous technology. But what is the real state of humanoid robots? How advanced are they? What can they actually do, and what remains impossible for them? In this long-form exploration, we go deeper than ever before, into the engineering, the intelligence, the limitations, the future predictions, and the global race to build the world's first truly capable humanoid worker. Let's begin with the world leaders of 2025. Tesla's Optimus Gen 2 has taken huge steps forward. Improved actuators allow smoother, more human-like motion. Its upgraded hands can now manipulate objects with far greater precision. Optimus uses Tesla's vast AI models, trained on millions of real-world tasks, to understand patterns and actions inside human environments. Video demonstrations show the robot walking confidently, balancing, picking up delicate items, and performing routine tasks with consistent reliability. Then we have Boston Dynamics Atlas, the world's most athletic robot. Atlas can run, jump, flip, spin, and navigate difficult environments with incredible physical coordination. Its entire design focuses on mobility, agility, and balance. Although Atlas is not designed for general labor, it represents the peak of robotic locomotion, a reminder of what machines can achieve when pure engineering is pushed to its limits. Digit, from Agility Robotics, takes a more practical approach. Digit is built specifically for warehouse tasks. Its backward-bending legs, unique design, and stable walking make it ideal for carrying packages, sorting items, and navigating crowded spaces. Companies like Amazon have already begun testing Digit in real operations. Figaro 1, created by Figure AI, is one of the most promising humanoids on the market. It is designed with safety, endurance, and utility in mind. Figure AI claims their robots may soon fill millions of job shortages across logistics, manufacturing, and retail. Recent demonstrations show the robot conversing, understanding tasks, and executing actions with a level of intelligence that feels surprisingly natural. Beyond these well-known examples, companies like 1X Technologies, Sanctuary AI, Engineered Arts, Unitree, UB Tech, and Fourier Intelligence are contributing to a rapidly growing ecosystem of humanoid machines, each with unique strengths and vision. But how do these robots actually function? A humanoid robot requires three main components: its body, its senses, and its mind. The body includes motors, actuators, joints, and stabilizers that allow movements similar to a human skeleton. Achieving balance is extremely difficult. Every step requires micro-adjustments based on hundreds of tiny calculations per second. The senses consist of cameras, depth sensors, microphones, touch sensors, and environmental scanners. These give the robot a basic understanding of space, objects, distances, and movements. And then there is the mind, the artificial intelligence models that interpret the environment, make decisions, and guide movement. These models are trained on massive datasets, sometimes billions of examples, allowing the robot to understand tasks, recognize objects, and respond to changes in its surroundings. Despite incredible progress, humanoid robots face significant challenges. Walking is still not fully solved. Most robots struggle with uneven surfaces, slippery floors, or sudden obstacles. They survive well-controlled environments, but the chaos of the real world remains difficult. Hands are another frontier. Human hands contain more than 30 joints and thousands of sensory receptors. Replicating this complexity with motors and pressure sensors is a monumental challenge. Robots often fail to pick up soft or thin objects, misjudge grip strength, or struggle with tasks that require fine motor skills. Battery life limits autonomy. Most humanoids operate for 1 or 2 hours before requiring a recharge. This restricts their usefulness for long shifts. social intelligence is also limited. Robots can mimic human gestures, but they do not feel emotions or perceive subtle cues. They cannot truly understand tone, context, or body language in a human-like way. However, progress is accelerating faster than ever. In the last 3 years, advancements in neural networks, multimodal AI models, and energy-efficient actuators have dramatically improved performance. Now let's explore where humanoid robots are actually being used. Factories are the first frontier. Robots assist with repetitive tasks, lifting, sorting, assembling, moving heavy materials. Companies adopting robots report fewer injuries and more stable productivity. Warehouses use humanoids for logistics, moving boxes, scanning items, transporting materials. Retail stores experiment with robots to stock shelves or assist with inventory. Japan and South Korea deploy humanoids in elderly care facilities. These robots help residents stand, sit, walk, and carry out simple physical routines. They do not replace caregivers, but they reduce physical strain and offer support. Hospitals test humanoids as mobility assistants or guides for visitors. Robots help transport medical supplies, carry equipment, and reduce workload during peak hours. And finally, humanoid robots are being used in environments too dangerous for humans: fire zones, chemical leaks, collapsed buildings, and unstable industrial sites. Now let's look toward the future. Experts predict that between 2025 and 2035, humanoid robots will become dramatically more common. Some forecasts estimate over 10 million humanoid robots working worldwide by the early 2030s. Improvements in AI will grant robots greater autonomy and adaptability. New actuators will allow more natural movement. Advanced tactile sensors will give robotic hands near human sensitivity. Battery technology will evolve, granting robots many hours of continuous operation. But with advancements come difficult questions. Will humanoid robots replace certain human jobs? Yes, especially repetitive or dangerous ones. Will robots enter homes? Most likely, yes. Early adopters may include people with disabilities, the elderly, or families seeking assistance with daily tasks. Will humanoids affect the economy, labor markets, and social structures? Absolutely. We will need new rules, new ethics, and new understandings of how humans and robots should coexist. Humanoid robots are not perfect, far from it. But they are improving every year, reaching milestones that once felt impossible. Today, they can walk, balance, lift, see, recognize, and adjust. Tomorrow, they may assist, collaborate, and transform the way we work and live. We stand at the beginning of a technological shift unlike any other. The rise of synthetic workers is real, and the world must be ready for what comes next. So what about you? Would you trust a humanoid robot to help you at work? Would you let one into your home? Do they excite you? Or do they make you uneasy? The future is unfolding, and humanoid robots are part of it. Thank you for joining Mind Odyssey. Stay curious, more journeys into the unknown are coming soon.